Hello. In this video, we present the resulting syntheses of valproic acid, according to the retrosyntheses shown in the previous video. The first strategy involves starting with lithium valerate, compound that only lacks the propyl chain at the number carbon-2 to be transformed into valproic acid, which is introduced using an equivalent of propyl bromide. The second strategy starts with a derivative of acetic acid, which can be methyl cyanoacetate or Meldrum's acid. The double alkylation with two equivalents of propyl bromide or propyl chloride. It also produces valproic acid. The third strategy is based on the carboxylation of trans-3-heptene. Lithium valerate, when treated with magnesium chloride exchanges, lithium for magnesium, and then it will react with LDA formed in situ to generate the anion at carbon-2, which is then alkylated with propyl bromide to obtain valproic acid with 51% overall yield. Methyl cyanoacetate reacts with propyl chloride in the presence of potassium carbonate, potassium iodide, and phase transfer agents, and is alkylated to form the disubstituted cyanoacetate 6. The series of treatments described here first cause the hydrolysis of the methyl ester, the decarboxylation of the formed carboxylic acid, and the hydrolysis of the cyano group to finally obtain valproic acid with 87% yield. It is noteworthy that in this synthetic route, the transformations in 6 can be carried out by isolating useful intermediates like 7 to form other compounds by reacting the methyl ester 6 in the presence of potassium chloride at high temperature that generates the corresponding carboxylic acid, which is then decarboxylated to form the cyano derivative 7, which can be isolated then treated with sodium perborate at high temperature that causes the dry hydrolysis of the cyano group, to finally form valproic acid with almost 83% yield. Following the same strategy, but now using Meldrum's acid, the alkylation with propyl chloride using potassium carbonate and phase transfer agents give rise to the substituted derivative 9, which is hydrolyzed in acid medium under microwave irradiation conditions to open the cycle and form the malonic acid derivative 10. The mono-decarboxylation of 10 is carried out under microwave irradiation conditions using substituted pyridine, supported on a polymer to generate valproic acid with 88% yield. The carboxylation of trans-3-heptene with carbon monoxide in the presence of water uses palladium chloride as a catalyst and oxygen to regenerate the catalyst. The yield is 75%, but the carboxylation of the double bond is not regioselective, and the ratio between valproic acid and the regioisomer 14 is 1:1. In summary, here the synthetic routes, their key raw materials, and their structural contribution are shown. Thank you for your attention.